I'm Mr. Chu. This is Bear Algebra. We're talking about solving systems of equations. Some students are confused by this. Make sure that you understand when to use the different methods. So just follow along here. I gave you challenge problems in my earlier video. Challenge 1 was the equation x plus 5y equals negative 3. And the second equation was 3x minus 5y equals 11. And I told you that the hint was the method that you could use, which would be addition, is when you have opposites. So I've got a 5y and a minus 5y. So we can add down and the 5y's will cancel out. So let's look and see how that works. So x plus 3x is 4x. The plus 5y, the minus 5y is 0. And the negative 3 plus 11 is 8. All right, if I have 4x equals 8, I have to solve that equation. So I can undo the multiplying by 4 by using the division property of equality and dividing by 4. 4 over 4 is 1. 1x over 1 is x. And 8 divided by 4 is 2. So I believe that the x coordinate is 2. So my solution, I believe, is going to be 2 and then something else here. So let's see what the y will be. So to find the y, I take either one of these equations and I plug a 2 in for my y. I'm just going to take the top one. It doesn't matter which one I take, but I'm going to substitute x equals 2 in here. So here's going to be my 2. I'm going to solve this two-step equation now by doing the inverse operation of adding 2. And that's subtracting 2 from the left, subtracting 2 from the right. 2 minus 2 is 0. 0 plus 5y is 5y. And negative 3 minus 2 is negative 5. I do the inverse operation of multiplying by 5, which means I divide by 5. The 5 over 5 is 1. 1 times y is y. And negative 5 divided by 5 is negative 1. So I'm going to make the statement that I believe that my solution is 2, negative 1. Now all I have to do now is check it by substituting into each equation 2, negative 1. For the 2 for the x, negative 1 for the y, and if it's true, it means that point is on the line. So, on my check here, so let's just write check here. And if I check the top one, x plus 5y equals negative 3, I substitute the 2 in for the x, and the negative 1 in for the y. I put a question mark above my equal sign and see if that's true. So 2 plus negative 5, does that equal negative 3? 2 plus negative 5 is negative 3, and negative 3 equals negative 3, which means that that particular one is on the line. Okay, so now you're saying, well, now what do I do? Now I'm going to check the second equation. So, let me write it over here. I have my 3x minus 5y equals 11. And what do? Wherever I have an x, I'm going to put a 2. And where I have a y, I'm going to put a negative 1. So 3 times 2 minus 5 times negative 1, I'm saying, does that equal 11? Well, 3 times 2 is 6. Negative 5 times negative 1 is 5. Does 6 plus 5 equal 11? Sure does. And there's my check mark. And if it's on both, that point is on both lines, it means that's where they intersect. So the solution is 2, negative 1. Remember, when you're doing a problem and you're solving it using elimination, if you have opposites, the easiest thing to do is just use addition. Now, in my new videos that I'm going to post, it will be different methods, but let's use this. It's easy. I add down. So 7x, this is 0 here, equals 35. I don't want 7x's, I want 1x. So I divide by 7 using the division property of equality. 7 over 7 is 1. 1 times x is x. So x equals 5. If x equals 5, now I can find what y equals by substituting. So the solution, I believe, is going to be 5 something. Well, I don't know what the something is until I find it. So I take an equation, doesn't matter which one, I'll just go ahead and use the top one. They both will work, and I put a 5 wherever the x is. Now I'm going to solve it. 3 times 5 is 15. Minus 6y equals 3. Now this is a two-step equation. I have to use 2 inverses. So I have to get rid of my 15 by subtracting 15 using the subtraction property of equality. 15 minus 15 is 0, and 0 minus 6y is negative 6y, and that equals negative 12. 3 minus 15 is negative 12. Now I'm going to take, and I'm going to rewrite this over here, because I'm running out of room. Negative 6y equals negative 12. Now I'm going to divide by negative 6 by using the division property of equality. Negative 6 over negative 6 is 1. 1 times y is y. A negative divided by negative is a positive. 12 divided by 6 is 2. So I believe the y coordinate is 2. So now I'm going to take, and here is my x coordinate, and here's my y coordinate when I'm doing my check. So now for my check, I'm going to take and write each equation down, substitute a 5 for the x, a 2 for the y, and see if it is true. And if they're both true, that means it's the solution. If only one of them's true, it means that you made a mistake and you got to go back and fix it. So here's my first equation. Now I'm going to plug a 5 in for my x and a 2 in for my y and see if that's true. 3 times 5 is 15, minus 6 times 2 is 12. Does that equal 3? It sure does. And what does that mean? That means that the 0.52 does lie on this first line when I graph it. Now, if it lies on the second one, it means that it is the solution for that particular system of equations. So now I'm going to write down the second one. Plus 6y equals 32. So now I'm going to substitute 5 for the x, 2 for the y. Put a question mark above the equal sign. 4 times 5 is 20. 6 times 2 is 12. I'm doing the order of operations now. Equals 32. 32 equals 32 So since they both are on there, that is the solution. All right, so it's a lot of steps, a lot of work, but if you show it all, you should be able to come up with the solution to the system of equations using elimination and addition. Why do we use addition? Because one of them went away, canceled out when we added. And we'll add a new method in the next videos. So up here will be my original lesson when I first introduced it. Down here will be the rest of the Unit 6 in Bare Algebra. I'm Mr. Chu. Make sure you subscribe to my YouTube channel so that you can understand algebra better by using Bare Algebra videos. I'll see you next time. Thanks for watching.